So to introduce the differentiation rules for exponential functions, we have the following. Let's just note that we can take any value b and we can set it equal to now e raised to the natural log of b, just like that. Because e and natural log are inverses of one another's. Okay? So what we've got here is a situation where we can take and rewrite b in terms of both an exponential function and a logarithmic function. So this says that we've got the following. We have b raised to the x would be equal to e to the natural log of b raised to the x. And we know that this right here, we can drop the x up front. So this is e x natural log of b, just like that. So now what we can do is our differentiation. So let's say we want to differentiate b to the x. Well, that is just differentiating this guy, e x natural log of b. But now we know what the derivative of this is. So we're going to go ahead and we're going to use our chain rule. Okay. So I'm going to let x natural log of b be equal to, let's say, u. Then this becomes d dx of e to the u. But the problem here is that we can't differentiate with respect to x because u is a function of x. So what we need to do is the chain rule. So this becomes du dx times, whoops, I want to take that guy out, times d du of e to the u. Well, we know d du of e to the u is just e to the u. And that is because we defined e to be the guy whose derivative is itself. Okay? So this gives us du dx times e to the u. But now, let's shift it back over here. But now we know, we'll get to du dx in a second here. Okay? But u was equal to x natural log of b. So this is x natural log of b, just like that. And now the natural log of b right here, that's just a number. Whatever b is, the natural log of it, this is a number. Okay. And so, now as long as b is positive, right? I mean, b is not going to be negative here. Okay. But so now let's go through this. We've got du dx, the derivative with respect to x is just the natural log of b, like that. So this is just natural log of b times e to the x natural log excuse me, of b. And we know that e to the x natural log of b is b to the x. That's this right here. And so this becomes natural log of b times b to the x. And that's it. It's pretty slick. Okay. So what we have is, if we want to take the derivative, like let's say d dx of 2 to the x, this will be equal to the natural log of 2 times 2 to the x, just like that. If we want to take the derivative of, let's say, 5 to the x, like that, that's just going to be equal to the natural log of 5 times 5 to the x. And now we can check, if we take d dx of e to the x, that's just equal to the natural log of e times e to the x. And we know the natural log of e is 1. So this is just e to the x. Hence, the derivative of e to the x is its own derivative.